video, I will be explaining 3 physics concepts in the sport of hockey. They're conservation of energy, Newton's laws in collisions, and torque. So in this video, I'm going to be talking about conservation of energy when you're shooting with a hockey stick. So the first important thing you got to know is that you can model the stick like a spring. And so when you're taking a slap shot, when you're coming down, that's all kinetic energy like that. And then you're going to transfer it into potential energy when you hit the ground like that. Because when you put it into slow motion, you come down, you hit the ground, you're flexing the stick like that, and that's putting it from kinetic to potential. And then as you follow through, it turns that potential energy into kinetic energy when the stick blade transfers the energy into the puck.
As we watch it back in slow-mo, you can really see the stick bend as I push down into the ground, storing all that potential energy. And when I follow through, the stick snaps back into its regular position and transfers that potential energy into kinetic. Also in the still image, I've highlighted how much the stick bends to show that the potential energy is being stored in the stick. All of this can only be true because energy is conserved in the stick and puck system. This next section will demonstrate Newton's laws while skating. Because hockey is played on ice, you cannot just run normally. Instead, you have to push out to the side as you skate. This pushing motion causes players to move forward because of Newton's third law. Because as the player pushes into the ice, it exerts equal and opposite force back onto the player. Using the force we get from Newton's third law, when we put it into the Newton's second law equation, we see that acceleration equals force over mass. So with more force being pushed into the ice, the faster you will accelerate. The next video, we're going to analyze Newton's laws in the open ice collision.
To battle. Silverberg trying to make something happen. Oh, he just got lit up.
This video, we see an example of Newton's first law, which is an object in motion will remain in motion until it interacts with another object in a way that produces a net force. In this case, it was an opposing player that caused this other force. This is also a partially inelastic collision because momentum is conserved, but kinetic energy is not the same because you lose some to heat and sound. We also see an example of Newton's third law, which is the force pairs law, which means for every force there's an equal and opposite reaction. You see that because obviously there's 2 players colliding, and that means they both exert the same amount of force on each other when they collided. In this last section, you will see how big hits demonstrate the concept of torque.
And it's McGinn. He's done a pretty good job of decimating the entire Vancouver defense. I mean, he got rid of Ehrhoff and Rome last game and tries to...
And look how well timed this is by Mathot.
Play defensively. Duchesne full blast. Up and over you go. All of that and more to come with the NHL on CSN. Superman in DC.
In most hockey hits, the 2 players just bounced off each other, but in these examples, one of the players starts rotating over the other player because of a thing called torque, and torque is a force that causes rotation around a point. In these examples, players are hit below their center of mass and near their knees. This distance between the center of mass and the point of contact gives us the R value in the torque equation. Using these details, we can tell that if a player wants to make another rotate, they'll have to hit them lower and with more force. When the average person watches a hockey game, they're simply enjoying the sport. However, the next time you watch a hockey game, you will understand the physics behind it.